Well, hello everybody and welcome back to the bench. Really hot day out today. It's about, wow, last I checked it was about 96 degrees Fahrenheit, so it's pretty warm today. So we got the air conditioning going in the house, and so we'll hear a little bit of background noise of that. But anyhow, off to our next project, and they're really starting to stack up, so need to get busy here. What we got for this project is a Pioneer model SX-3900, and it's a little bit unique. It's considered, this line here is considered the last of what they refer to the vintage silver face line of the Pioneers. And this one's kind of a transitional piece in that, as you can see on the front, it does have an analog dial, but it also has a digital display. So it's kind of a unique tuner in that it not only shows you the digital, but the analog display face, which that's kind of a novelty, but I think that was kind of a sign of the times of all of the analog things were falling out of favor, and everybody wanted to get into all the digital stuff. So now digital, it can mean a bunch of different things. Some digital tuners were true digital, and in that you had, you know, a synthesized front end and so forth, and it was actually tuning it that way. But some of the tuners from this era, and I've worked on several, have a normal tuning gang and actually were a standard analog tuner. Nothing special about them, except they just used a frequency counter at the front end to simulate a digital tuner. Now, I have not serviced one of these yet, so when we get it apart, we'll kind of look at it. And I haven't really even looked at the schematics. I have all the service documentation on this, but never really messed with it too much. So we'll have a look-see inside here. I have a feeling this is kind of, you know, similar to all the other ones where it'll have a, you know, PLL for the multiplex circuit and all that, but it'll have a standard analog front end. But we'll see. We'll take a look at what's going on with it and how it's put together, and then we'll go through it. It is pretty crusty, so if you look down here, a lot of dirt and dust and stuff that's going to need really well cleaned out. And of course we'll have to plug it in and test it and see what all goes on. But before I ever plug any of these in, I always take the cover off, make sure that nothing got shorted out or nothing's rattling around in there, or something came loose or something in transport when it got shipped over. So we're going to check that first, and well, we'll see where we go from there. Well, here's a first. We got this all over the inside of it, and it's not dirt. Let's zoom in a little bit, see if you can identify what that is. You see that? And if you look, it's down in there. It's sawdust. Obviously, somebody must have had this in their wood shop or something. A lot of times these old classic receivers, a lot of people don't even know what they have, and they get relegated to the to the level of going into someone's garage and or workshop and being connected there just to listen to some music while you're working, not knowing that these were actually really high-end receivers. Again, the SX-3900 was one of the high-end top-of-the-line receivers during the year that they were manufactured with Pioneer. This is a 120 watt per channel receiver, and I think the distortion is only like 0.005% total harmonic distortion at full power. It's kind of unique the way they did some things in here, so I was kind of looking it over. One of the things I noticed is you have two power transformers. You have this toroid transformer, which they were using for a while to drive the output stage on this, but then they have a standard transformer down here that they're using for some of the other power supplies. And there's yet even another little transformer that's used for driving the little vacuum fluorescent display that they have for the tuner. And in just kind of looking at it, I haven't read the theory of operations or anything yet on this, but this looks like a standard analog tuner with quartz lock IF, a quartz lock circuit on it, and it's basically just using a frequency counter. That's it, to sample and display the frequency. So again, I could be wrong, and as I read a little more and work on this a little more, we'll figure it out. But like I said, this generation of receiver, I haven't really worked on a whole lot of these. This particular, at least this is the first 3900 or 3800 for that matter. They're about the same other than power that I've worked on. So let's get it cleaned up, get rid of the sawdust, and before the termites show up and eat our receiver, and then we can start doing some tests. Okay, this thing's a little bit crusty here. We got a station tuned in and an antenna connected. And it is really kind of rough sounding. This channel so part of that could just be noisy controls. Part of it could be the multiplex circuit. Let's see if we can turn this into let's see if this thing has, yep, mono. Nope. And you can hear it just cuts out. So I don't know. Definitely has some issues with it. But it does have sound in both channels. And I do see the power meters deflecting when I turn the volume up, and they deflect relatively equally. They're off a little bit. So it could be in the front end. It's not the output, which is good news. But we'll have to go through and clean the controls. This thing does need a good cleaning. I started brushing and vacuuming some of the crud out of it, but man, that sawdust is everywhere, and it's just kind of stuck up here. You really got to rub to get it to come loose. So this restoration is going to be as much of a cleaning job as anything else. So let me finish cleaning it up. I'll spray some of the controls and see if that comes back, and then we'll start working on it from there. Okay, the unbalance in the channels is actually the tone section here, and part of it is because if you look, this this treble knob is pretty bad. So we'll have to look at that and see. I have to be very careful with that it doesn't get broken. See where we're at with it. And just by and large, everything is filthy dirty. So we're going to have to go through the tone control section, obviously. I'll have to get with the owner and see if they want to do a recap on this, or if they just want it cleaned up and aligned, or what they want. Actually, this thing's been sitting for a while. I've had it for a while and just haven't gotten around to getting to it till now. So I'll have to find out again what he wanted. So, all right, moving on. All right, the first thing we're going to deal with is these noisy controls and all the dirt inside here, and I just keep getting more and more sawdust out of this thing. So I don't know if who this was owned by, but he must have been a woodworker. Anyways, you can see how the design really changed in the Pioneer gear with this model. There's some unique things in here. Number one, they have like a different type of volume knob, very good quality. The actual pots went to these little small potentiometers, these small diameter ones, and they're all like that if you look. A couple other unique things, 7,000 screws, and it's kind of like the SX-750s where you have to take a whole bunch of screws out to get this metal plate off. But if you look here, this is pretty unique. These are some of those slide switches, and you can see them in there. And as you toggle them, there's a track here, this little plastic track, and you can see how it goes in there. It goes all the way back, and it comes around, and it goes clear over here. I don't know if I can see it on the camera or not. It goes clear down here. You see it right there, the light touching it, and the actual switch is all the way back here. And so when you toggle this switch, you're actually moving that little shifter slider inside there. It's like a little sliding metal piece of spring steel or a little piece of mylar or something in there inside that track, and it slides back and forth and moves the selector switch. Pretty interesting how they do that. All of this stuff was done in the name of keeping the distortion and the noise to an absolute minimum by moving the switches clear back by the actual connectors themselves. Obviously, you're reducing the possibility for picking up unwanted noise by having wires and so forth in there. Same thing with these selector switches here. They're little plastic push rods, and they go along here, and the actual switches are back here. If you recall, in all the earlier model Pioneers, these switches were mounted right up on the faceplate, and then they had wires or something, you know, bunches of coaxes. They actually have all of them now right back by the switches. So again, an attempt to keep things quiet. Now, a few of the things I don't like that I see already is it does use those super match transistor packages that we have seen in some of the other videos, and that's right here. You can see they have 5 pins, and the reason there's 5 pins is because there are 2 transistors in each of these packages. They're super matched and connected together thermally, and depending on the transistor type, it's either going to have, like, the collectors or the emitters could be tied together. And again, you'd have to look it up, and you got to watch you don't get any counterfeit ones, because the pinout could be different, and we saw that on some prior videos. So pretty interesting. So again, this will be quite a task just because of all the disassembly involved to be able to get in here and do the cleaning and the recap and just the overall basic restoration of this receiver. It does have reduced power output. There's something wrong that we're not getting full volume. I don't think it's the output section, because it seems to be symmetrical between left and right channel, so it might be something to do with the power supply or something like that. But I really want to rule out the simple things first, which is cleaning the controls and making sure that there's not any problems with those first. Once we know that's all good and all this is cleaned up, and while I'm in here, I did talk to the owner. They want everything recapped. They want the full treatment done to this receiver. So I'll probably go through and recap the front end of this receiver. Then we'll go back in and we'll start checking power supplies and doing some things like that. So just thought it'd be interesting for you to see how they have this thing put together, and it's definitely not not easy to get apart. Just have to be patient. All right, we'll be back. Okay, I must say this is one of the more difficult receivers I've had to take apart. Everything is wire wrapped to everything and wrapped around the chassis and around all the boards. So this is not a beginner's receiver to service. As you can see here on the board, this is the main amplifier board. It's all covered with kind of all this crusty sawdust stuff we have to get all cleaned out. Even the protect relay, everything is on this board here. You can't really pull it out too much because all these transformer wires under here and the diode board and everything is underneath here. The power supply is here. There's all kinds of wires holding it that we have to take off in order to get this out and mark them. So this is a very challenging little board to do, or little receiver to do. So lots and lots of work. If you want to recap and restore one of these, plan on it being a very meticulous job. And of course, everything you take apart, you have to put back together. So, yeah. So that's where we are. We're moving along. We got the tone board done. I got that fixed up and got it recapped and cleaned. So now we got to kind of focus on all these boards that are all tied together here. So just thought I'd share that. We are now getting into extreme disassembly. I just wanted to show you guys how far you really have to tear this particular receiver down just to gain access to the components, to clean it and to recap it, and so forth, to test it out. You can see we have part of it's recapped already here. I'm going to work on this up here on the switchboard, and I have the amplifier. Let me grab it. So here's the amplifier. You can see it. Great big heat sink. And here's those funny MT200 type transistors. And you can see how they're just kind of held in here with these funny little loose plug things. I'm really not a fan of this. Basically, these were kind of an interim between the TO3, those oval shaped metal transistors you're used to seeing on a lot of my other videos, and the newer what's called, let me see if I have one here, TO3P transistors, which I got one here. I'll show you. This is a TO3P, and they're larger, and they're a single mounting stud instead of two screws. A little easier to work with, but yeah, I mean, you see they had to put these little brackets on here to hold it on. Kind of a weird design. So anyways, this amp is all, the amplifier module is all cleaned, and the couple of capacitors have been replaced. I still need to go over this relay and make sure it's good. Check the contacts on it, make sure they're good and everything. And I think they are in perfect condition. And yeah, this is how much you got to do to get into this thing, and actually, if you want to do a recap and a cleaning of it. And I cannot tell you how much sawdust has come out of this. You can see I started working on this area up here, and there's a little area I started cleaning, and essentially what I'm doing is I'm using some anhydrous alcohol. Anhydrous alcohol has no water content. It's pure alcohol, so it totally and completely evaporates. And you can see, well, let's try to zoom in a little bit. You see here. I don't know if this will show it. Right there. See if it'll focus. There it goes. And you can see, like right over here where there's all the dirt and everything, and you can see this little area down here that I started to clean. There's just this sawdust, and it just kind of got wet or damp and just kind of glued itself onto the board, and I've just kind of had to go through and meticulously brush it off. And this has just been a seriously long, tedious, hard, difficult job. But really, to restore these kinds of receivers that are built like this is what you have to do. And you really got to take a lot of pictures and take your time. Be careful not to break anything on the way. And that's it. So once I get this finished up, we'll start putting it back together, and then we'll come back. Alright, sorry about all the noise here, because I got the desoldering station going, and I have the air conditioning going in the house because it's hot again today. So lots of background noise, sorry about it. But I thought you'd be interested. I get a lot of questions. You know, can you show us replacing the capacitors when you're recapping one of these things? And this is a pretty extreme example, so I thought it would be a good one to show. And I'm just going to go through the process of doing one or two capacitors. as you can see, sometimes you cannot get without major disassembly. Well, we already have major disassembly, but even worse, you know, I don't want to disconnect the dial cord from the tuning gang and all that. This board is all one great big board all the way here, and it is really connected in here, and it's very difficult to remove. The other problem is you have this, if you look, there's a brace in here that's in the way. There's a brace on the back here that's in the way that you can't remove because of the way it's interlocked. So how do you get in here and remove these capacitors? And by the way, on this side, if you look, you have this board blocking access to the top of this board. So I'll show you how I do it. I always try to do as least amount of invasiveness as possible when replacing these. Now sometimes, as you can see, you really have to tear these down to get to them, but you know, that's what you have to do if you want to recap these things. So what I have here to help me out that I use, and I'll back you out here a little bit, is these. It's a big pair of needle nose pliers, and they're articulating like that so that they don't take up a lot of space when you're opening and closing them. And you can't really see, but if you look closely, I have a piece of clear, this is very soft rubbery type heat shrink over the tips. And now it's kind of more like dentistry than it is electronics, because it's kind of like pulling a tooth. So you go on the back here and you desolder the pins, and then you come back in here, and let's see how close we can get in to be able to see where we are. And I'm going to have to try to work around the camera. So I just removed the solder from this one right here, and I remove it, and as you can notice, the positive side of this electrolytic is facing up, and there's also a plus sign right there that you might be able to see. I don't know. Possibly. So you remove the capacitor, and then same thing goes for putting the new one in. So let me grab a replacement cap, and I'll show you how I put the new one in. Okay, so I have the new cap, and you put it in the pliers, and then it's just kind of like you fish it in there, and you have to be very careful, and you get it started, and there you go, and it's in. And then you get it straightened nice and neat, and you bend over the leads to hold it, and you're all done. That one's in. And basically that's been the process throughout this whole thing here, is what you just saw. Very, very time consuming, but if you want to do a proper recap of this, you really have to spend the time and patience to do it this way. Again, if we were able to remove the board and lay it flat like we were with the power amplifier board, much easier, because then you just kind of flip it over and remove the components and replace them. So really the only thing left to do now is I have a couple more caps on this big board, the main board, and then I just have to do these few up here on the display board. And that display board's kind of unique because that's where your frequency counter for the tuner and all that is on there. So again, going to be kind of challenging to reach in there, but it's going to be a similar process. Just thought I'd share that with you. Okay, so she's all back together now. And surprisingly enough, I only had one little issue after I got it together. Other than that, it worked perfectly. So after a quick little game of show me where you've been and I'll show you where the problem is, I realized that I forgot to plug in the little jumper that goes between the preamp out and the power amp in on the rear of the receiver. And that was the only problem I had. So the amp and tuner, everything is working perfectly. We got all the caps replaced, as you can see. Kind of pan around a little bit here. And there's all the ones that were replaced. A whole bunch of them. So now the thing to do is I did some looking at the schematics and so forth as I went through this and realized that, number one, this is one of those zero switching design amplifiers. Zero switching amps is a term that Pioneer used. Some other companies called it the new Class A, which it is really not a Class A. And essentially what's happening is they have a little servo circuit that they build into the power section there that prevents the outputs from actually turning off when you're in your, in the opposite half cycle of that transistor. So Class AB, you're putting a little bit of bias on both transistors so that there is this point in time where when they cross over from, handing off the waveform from the one side to the other, that basically prevents them from having any kind of crossover distortion. What they tried to do with this zero switching, in a nutshell, is they tried to take it a step even further to the point where when the circuit recognizes that it's in the opposite half cycle, it will prevent the transistor from ever turning off. So it keeps the transistor biased on at all times. Supposedly that's supposed to make the amplifier have even lower distortion. I don't really know. Maybe it is, but it would be only on sensitive test equipment, and at least with my ears it doesn't make a big difference, but it's a neat design. The other thing I noticed about this is it has those really bad J-FETs. It's like a, well, let me show you what I found. Yeah, here it is. So here's just like an expanded, I kind of blew up this section a little bit to make it easier to see, of the power supply. And if you look in the power supply, you see these little J-FETs, and all they're doing is they're tying the two legs together. So really this is only working, as a, they're basically using it as a constant current source. And the problem is this is a special J-FET. I think it's a 2N34 or 2N39, something like that. It's a regular J-FET that has a abnormally high voltage rating. So it has a higher voltage rating than a standard J-FET that you would normally have. So they don't really make them anymore. They're hard to come by. And even if you do find them and they're not that expensive, this circuit is very prone to failure, because even though these are higher voltage rating, these circuits, this is in the SX-3900 as well. These circuits tend to run them near their limits and they fail. And when they fail, all these transistors, all kinds of things will burn up. So one of the mods that people do on these is to replace them with a little constant current circuit module. It's a little homemade thing. I'll show you one here that I got out. You can make these with a couple of transistors, NPN and a PNP, and a couple of LEDs, and essentially it will do the same, it will achieve the same purpose as that little J-FET that's got two legs tied together like that. And this is much more robust and can handle a lot higher voltages, not so susceptible to failing. So the problem is it's really tight to get it in there. If you look down in here, this board that's underneath this board is where that's located. It looks like it would be really difficult for me to do that. I don't know that anybody's ever tried it on one of these. But the power supply in this one was in really good condition. It didn't even have any heat marks on the transistors. The other thing is this, other than recapping it, I kept this thing totally stock. In other words, I did not modify, change, upgrade anything in here, because I just wanted to make it work properly how it's supposed to before we make any changes. Afterwards, then we'll make the choice whether we want to do any mods to this thing. These zero switching amplifiers run really hot. Even just me messing around with it a little bit, these heat sinks really got warm without even driving any power. Just sitting there, it gets hot. The other thing is these power supply transistors, almost all the big Pioneers, they get really hot and they'll fail after time. So another mod to do would be, there's some much beefier transistors that can be substituted in there they run a little bit cooler for some reason, and they have a lot higher dissipation than the ones that are in there. Again, big pain in the butt to take everything apart again and do that. I don't know whether I want to do it. Everything is working perfectly right now. So I may have a little talk with the owner, see just how far he wants to go with this. But what we're going to do for the rest of this video, and then we're going to end it, is we're going to do the alignment on the amplifier and the alignment on the tuner, and then we're going to call this part 1, or just call this the video. Then if they decide to do any mods on the power supply, we'll come back and do that on another separate video. So let's get into the alignments, and then at least we'll see how that works on this, because it's a little bit different on this than on a standard amp. So first thing we're going to do, amplifier alignment. Okay, I now have the amplifier turned on, and I have the terminals, the voltmeters across the output terminals where the speakers would be, and we're going to first set our DC balance. Now, prior to doing this, the instructions tell you to take the 2 bias pots on either side of the amplifier. Yes, there are 2 bias pots per channel, and turn them all the way counterclockwise to basically turn everything off. Then they want you to do the DC balance that way. So you can see, if we move up to our meters, we have our 2 voltages there, and let's see why I'm getting reflection. Who knows where that's coming from, but anyways, you can see it. So we have about 8 or 9 millivolts here, and of course it's pretty much balanced there. And what they want is they want it to be balanced within plus or minus 30 millivolts. So these are actually perfect right now, and you'll see they jump around and drift around a little bit as the temperatures change in the transistors. As this warms up, this will creep around. So it's kind of one of those things where you have to sit there and wait for a while till it warms up, and if everything stays like this, then we just leave it alone. If not, we use these 2 blue potentiometers right here in the middle of the board, one here and one here, right and left channels, and we just adjust it for 0 volts DC, and that's all we're going to do. That's the balance. That's step 1. Okay, for step 2, we have to connect the meters to these 4 test points, and they are TP 11, 12, 9, 10, 11, and 12. Unfortunately, on this particular receiver, when I got it, the test point holes were there in the board, but there were no posts soldered into the board. I don't know why. It was just like that from the factory. So of course I had to take the whole board back out and put a couple wires in there, and you can see I just put a couple of stiff wires in there, soldered them in, and now we have the test points that we need. So we're connected up, and remember, these are all turned all the way down to minimum, and what they want us to do is go to the meter, and you're going to adjust these test points in 2 steps, and it doesn't make sense when you first read it. The first thing they want you to do is they want you to adjust VR3 for the left channel and VR4 for the right channel for 56 millivolts on these test points. Then they tell you to turn around and adjust VR5 and VR6 on the same test points. In other words, we don't move our meter, and we readjust that same test point for 70 millivolts. So you're having, what this is, I believe, is that servo circuit, and you're setting up the idle, the do not exceed or do not go below bias current for the zero switching circuit, and then you're setting your 70 millivolts would be for your standard class AB bias. So that's why they do it that way. So what's going to happen is when the amplifier starts to operate, when the signal goes to swing into the opposite phase, or what's going to happen is it's never going to let that other side go below this. So that's what's going on. So let's do those adjustments now. So the first thing we're going to do is move our meter, or move up to our meters here, and we're going to adjust VR3 and VR4, which are the first set of pots. By the way, I'll show them to you. That would be this pot and this pot right here. So here and here, we're going to adjust those for our 56 millivolts. So here we go. So I've got my first one. We're adjusting the top meter right now. And you have to just kind of adjust it a little bit, and we're going to let it settle. I'm going to stop there, and I'm going to go to the other channel while that one's settling and move this one. And this one's kind of noisy. And then you can see this top one's kind of going up on its own. And you can see this one's climbing and creeping up. As the transistors heat up when you make these adjustments, you'll get a little bit of thermal reaction there, and it's going to cause these to creep up. So I always go a little bit low, let it creep up past it a little bit, and then I'll come back and back it off a little bit. So that's all we're going to do, is we're just going to sit here and watch this. I'm going to go back and forth till I have my 56 millivolts on there and have it sitting there properly and not drifting too much after that. So we'll be right back. Okay, it's settling in right around there, and we're within 1 millivolt, and I'm happy with that. So now what they're going to have us do is we're going to take the other two pots and the last two pots, and we're going to adjust those to bring the test points now up to 70 millivolts. So you can see how they're doing this. So let's adjust our next one, top meter first. And there you go. And again, this is going to float around a little bit, and all we're going to do is just kind of let it settle. Now we'll go to the other one, bottom meter. All right. And then once again, we're just going to let it sit and make sure that it kind of stays right around that 70. Again, plus or minus 1 millivolt. You're going to have that because transistors drift with temperature. And this is just, you can't get around it. So there it is. That's all we do. After this, the amplifier is done. And we're going to move on to the power output power meter alignment. Okay, to align the amplifier's output power meter, you have to put a 1 kilohertz sine wave into the power amp input terminals. So those jumpers that I forgot to put in, I need to take back out. I connected them back in, and then you just adjust the output of your signal generator until you get an output across your dry terminals. In other words, no, you don't want any kind of no load or anything on it, and you go till you have 8.95 volts RMS, AC RMS, coming out of the amplifier, and that, with that 8.95 volts, you adjust VR1 and VR2 on the power board until you get, as you can see, 10 watts reading right out on the meter there. And of course it's right on. I didn't have to adjust it, so that was correct. So there you go. Simple as that. And by the way, VR1 and VR2, if you do need to adjust them, are right down there. And they're right in front of the big power transformer. You can see there in front of the heatsink. And that's it. Okay, we have our scope set up. We have our 1 kilohertz signal going in. And we're going to do our maximum power. And you can see down here it'll read the RMS voltage. And just see where we're at. So let's bring it up. So there's clipping. And there it's kind of gone. And we're somewhere around 31.6. So 31.6. Remember, I'm looking at the times 10 on my dummy load. So whatever you have there, you have to times it by 10. And 31.6 squared divided by 8. 124.82 watts per channel. So 124 watts per channel, and this amp is rated at 120 watts per channel. So there you go. Now the other thing they're trying to say is that crossover distortion is supposed to be really, really good on this. So we're going to go and take a look at this and see what our crossover distortion is. I'm going to change the settings on the scope to make it real sensitive. Hold on. Okay, we're only at 100 millivolts per division, so this USB oscilloscope is very susceptible to noise. It's not nearly as good as a high-end scope. So this zigzaggy stuff on here is just the scope. But you can see at the zero crossing, there is absolutely no crossover distortion whatsoever. And of course, that's, you'd see that on a standard class AB amp if it was properly designed and properly biased and everything. You'd still have that same thing, but it is working very well. And as we go up, and again, I got to change make this a little bit less sensitive. Let's get it from there. And you can see it's nice clean waveform. So there you go. The amplifier is working as advertised. And now we'll move on to the tuner alignment, which the tuner is a little bit out on this thing, I think, but we'll find out. And just for giggles and grins, there's a 1 kilohertz square wave. And actually there wasn't a whole lot of leading and trailing edge distortion at 20 kilohertz with the square wave. So and then let's go down to 100 hertz and move this down. Oh, too much. And you can see that even looks pretty good. And 20 hertz square wave. Once again, pretty good. So there you go. The amp's working great. Okay, we're at step 1 of our tuner alignment. And the first thing they want you to do, they always start you out with the FM alignment first. And the first step is nulling out the discriminator. Now, what we're going to do is we're on a test point down here, and we're going to adjust the 1 coil to null out the signal to 0 volts. And typically it's usually right on or pretty close, but this one surprisingly was off a good bit. It's 730 millivolts off, as you can see right here on the meter. So the idea of what we need to do, and I got the tool in there ready to go, is adjust it for 0 volts. So I'll try to do this so you can see. So we just kind of move down here, kind of let it settle a little bit. You can see it kind of already jumped on me. And let's change the range here, so there we go. And sometimes you have to adjust the range to a fixed, if you have an auto ranging meter, you have to adjust it to a fixed range so that it doesn't keep switching through the range when you get on the edge like that. And there you go, we're pretty close now. Now it's bouncing between the positive and negative. You see how the minus and positive, and that's what it's going to do. And you can see the minus will go away, come back, go away, come back. That's normal. So that's pretty much nulled out, and we're done with step 1. Okay, for the next step, we want to inject a 106 megahertz signal at somewhere around 500 millivolts. Through, at 300 ohms terminated, and we want to monitor the same test point as we did nulling out the discriminator with no signal. Now we're going to do with signal, and we're going to null it out, and you can see it's a little bit off. And to do that, right inside here there's an adjustment, and we're just going to adjust it to null that out. So let's do it. And these trimmers are always very, very, very touchy. You can see just by putting the tweaker on there and putting pressure on it, how it moves it. So, and you can see what you have to take away and just kind of do a little bit at a time. And just watch it. Okay, and we're getting there. And once again, we're going to have that situation where it's going to kind of bounce back and forth between the settings. Not easy. Okay. So I'm going to fiddle with this and let it settle rather than burn up a lot of memory here on my camera. And when I get it, I'll be back. Okay, and that's about as good as we're going to get it right now. And it'll kind of, if you just even breathe, if I blow on that, it'll buzz back and forth. So again, very, very touchy. All right, next step. Okay, we're now at 90 megahertz, so we're at the bottom part of the scale. We're going to do the same adjustment, same way, except now we're going to use this coil instead of this little capacitor. So we're just setting our dial accuracy here. So let me get on this. Okay. And you can see we're jumping back and forth again. Right about there is about as good as you're going to get it. And I'm also monitoring the distortion, which the THD should be somewhere between 0.1 and 0.2 when it's nulled out properly. That's about the best distortion with all this test equipment hooked up the way it is, and the errors in the receiver and the distortion in the signal generator, all those things add to it. That's as good as you're going to get. So we're all set. Our dial accuracy is set, and we're all nulled out. Next step. Okay, now what we're going to do is we're going to adjust the sensitivity of the tuner at both ranges, at the 106 megahertz and at 90 megahertz, starting with 106. At 106 megahertz, we're going to adjust the little trimmer capacitors on the tuning gang, and they're marked in blue. And we're also going to adjust a little coil back here, a little tuning can. And then for the 90 megahertz, we're going to adjust this coil, and then there's a couple little copper coils you can see right here and here that you just bend them a little bit in or out to maximize sensitivity. Now what I've done is I've driven down the signal very low till I'm just starting to get a little bit of crackling in the background sound. And if we look up at our oscilloscope here, let's see if I can zoom you in. Right there, you see how right here you're getting a little bit of noise at the bottom and it's clean at the top. What we're going to do is we're going to try to balance that noise to be equal on both halves. When we do that, we know we're right centered frequency, and we're also have the most sensitivity. And also, if we can increase the overall amplitude a little bit, that's our goal. So let's go in here, and I'm going to do these ones right here and that coil back there. So I'll put you back up on the scope here and we'll take a look. Okay, hold on, I have to get a better adjuster here. Okay, here we go. That's the wrong way. And there I just went through it the other way. Right about there. So that one was off just a little bit. Go to the next one. That one was, there we go. Pretty good. And while I'm doing this, I'm also looking at my distortion meter to make sure it's minimal. Okay. Okay, next one. One's not really that far out. It's pretty close. Okay. All right. Now to do the little coil. See, we're just about nulled out there. We got rid of about as much of that as we can. Okay, and that's it for that one. Okay, we're now at the 90 megahertz, and we're going to adjust those coils. And you can see this one's a little bit noisy, so we'll see if we can clean it up. Turn this first one. Yeah, I'm getting some there. And looks like I'm just going the other way. Right about there. Right there. That's about as good as we're going to get. And again, I have a very weak signal. I'm only putting about 10 microvolts right now. And that's before it goes through all these cables and test equipment. So that's pretty low signal right now. Let me do the next coils. Hold that thought. Okay, I bent those two little coils a little bit, and you can see it's almost exactly the same amplitude and signal strength as the 106 now. So now we have it balanced. So technically this tuner should be equally sensitive all the way across the board, and it should be pretty accurate. So now we're going to go to 98 megahertz, which is actually center of scale, and we're going to once again fine adjust everything for our discriminator and everything and null it out. So let me go and get set up for that. Okay, for this one we're going to go to the bottom core of this coil. This was the first coil, or the first transformer we adjusted at the very beginning. Now we're going to do the other one, and we're going to go for minimum distortion at 98 megahertz center of scale. And we're really close right now, so I have a feeling we're not even going to have to touch it. I put the adjuster in there. We're going to move up to our distortion meter, and we're just going to adjust it for the cleanest signal possible. And I have a feeling we were almost there to begin with. Yep, we were there. See how we're kind of nulled out. There. And it's getting even kind of dancing below 0.1. It'll get down there. So that's really good. So that's good. Perfect. And we have a perfect waveform at the amplitude they're asking for. So that's it for that. Now we're going to adjust our signal indicator and our muting. Okay, that's the next thing we're going to do. So let me get set up for that. Okay, to adjust the meter and the muting is this little pot down here that you can't really see underneath all this, and the muting is this one here. The meter is perfect. The muting is out though. With about 8 microvolts going into the tuner, it should unmute the muting circuit, and you can see it's muted right now. I have the volume on and this signal is muted. So we're going to adjust this till it just trips on. So, and you'll be able to hear it as soon as it comes on. There it went. Hear how loud? Okay, so now I'm going to turn it till it kicks off, and then come till it just goes right back on again, just barely. And right there is our muting is set. So that's it. All right, and here we are. So it's off center. Put it on. Off. Off. And there you go. Muting is set. So that does it for the FM section. Now we have to move on to the multiplex for the stereo FM. So let's get that set up, and we'll be right back. Okay, we're getting set for the multiplex adjustment. And the first thing we have to do is set up our test equipment. I'll go over that with you real quick. Up here, we have the signal generator set to external modulation. So this signal in here is coming out of our SG-165. We're using that as a multiplex signal generator. So we're taking our multiplex signal and we're FM modulating it into 98 megahertz carrier. They want 500 microvolts of drive signal into the antenna. And then we're going to take our frequency counter right here, and it's supposed to be set to 76 kilohertz, and you can see that it's already almost dead on. It's very, very close. And they do that by checking test point 6, which you can see is right down in here on the main tuner board. So, and to adjust that, we're going to adjust VR5, which is, See if I can find it in here someplace. VR5. You have to give me a second to find it. Okay, VR5 is actually hiding right under the tuning flywheel right here. So we're just going to adjust that until we have dead on 76 kilohertz, which I think we're pretty close right now, but we'll see if we can get it right on. But usually, once again, this is one of those kind of not a perfect world things, and it's going to jump around, but we'll see what we can do. This is close enough though, it will work, but I always try to get it as close as possible. So let's see if I can get in there and make the adjustment. Nope, that's about all we're going to get out of it. So that's kind of what I thought. Okay, so let's go on to our next alignment. Okay, I now have the modulated signal going into the tuner, and I'm tuned into a on 98 megahertz, and I have my stereo indicator, and you can see your right and left channel information. And you can also see that by going to multiplex, the overall amplitude reduces. If you recall from when it was a just a straight mono FM, the amplitude was much higher. Alright, so you can see the stereo on there. The next thing we're going to do is we're going to adjust the to be able to make sure that when you turn off the left and right channels individually, that it suppresses the other channel properly. So we're basically adjusting our 19 kilohertz pilot tone properly. So we have both channels on right now. We're going to shut off the first one, and you can see that line is relatively straight, and we're going to go ahead and make the adjustment, and you can see how it distorts. And what we want to do is adjust that till it's as straight as possible. Then we're going to flip the other channel and change our trigger, and you can see that one's nice and flat now also. So that part's done. Again, a lot of these are close, and they should be, because there shouldn't be any big problems. So there you go. Both channels on, everything is good. So we have a nice stereo signal, and that part's all set. So next step. Okay, we're now going to align the crystal detector, and step one, we're going to connect our meter, which I already have, between TP9 and ground, and then we're going to adjust the core over here to 0 volts, and that's pretty much all there is to it on the detector assembly. So we're going to set our detector to 0 here, then we're going to null it out. So you can see this one's off a bit, it's pretty high. So let's see, bring it down. Whoop, too much. This is very touchy. And we're going to null it right out there. Very good. I think 0.36 millivolts is good enough. All right, next step. Okay, now we're going to, and that last step, we're just putting a carrier signal, so there was no modulation. Now we're going to add a 400 hertz modulation tone, and leaving everything else the same. And we're going to just adjust for minimal AC signal between TP9 and ground. And we're going to use the other slug of that same detector circuit, and we're going to just adjust that now. See if it does anything. Yeah. I don't know how much we're going to get, but that's an awful lot of adjustment. So it looks like that's about all we're going to get out of it. All right. Oh, it's starting to go back up. So there's the null point right there. Right there. That's it. So that was quite a bit of adjustment on there to get that to null out down there. And it says to minimize AC signal level. You're not setting it to 0. You're just getting that null point where it's as low as possible. So there it is. And that's supposed to be pretty much it for that. All right. So last but not least is adjusting the frequency counter, the digital frequency display, to match the analog display. And actually it is absolutely dead on all the way across the board, so there's no need to adjust it. If it did need adjusted, it's very simple. You just, as long as you have an accurate signal generator and a known good signal, you tune it in, and then you just adjust this little trimmer right here to make the frequency counter match your analog dial. Again, it's cool that it has a digital frequency counter readout, but it's kind of strange that you have the analog and the digital at the same time. So yeah, but you can see it right there. I'll lift it up a little bit so you can see what I've been working with. So there you go. The tuner is done. That's all there is to the tuner for the FM and the multiplex. And now all we have to do is the AM. And I know I skipped over the AM on the last couple of receivers that I did, so maybe I'll show this one real quick. It's pretty simple and straightforward, but we'll go ahead and do it. Okay, to do the AM alignment, you need one of these, which almost all of these receivers use this. You're just taking a 1K resistor, and you're putting the 1K resistor in line with your signal generator, just like that, and then you're connecting it to the AM antenna input on the rear of the tuner. So that's all I'm going to do, and then I'll be right back. Okay, for step 1, we just set our signal generator to 50 millivolts, which is a pretty powerful output, at 600 kilohertz, and you want to modulate 400 hertz modulation at 30% modulation. And we're going to adjust this little adjuster coil right down here behind this. You can see it down here, just barely see it. There it is. There, it's pretty clear. So we're going to adjust this for maximum amplitude on our scope. So we're going to move this, and I'm going to go, we're going to go for maximum amplitude. Let me move your scope up here so you can see. And there we go. So let's see what we get. Wrong way. Wrong way. Let's go. Right about there, huh? Right there. Perfect. Okay, so that's done. Now we go to step 2. Okay, we now move on to the 1400 kilohertz, and we're going to use the remaining 2 adjusters on the tuning gang to adjust the AM amplitude. And it's off right now. It's off frequency at the 1400. It was pretty close on the on the 600, but on the 1400 it's a bit off. So let's get on the scope here, take a look, and we'll adjust and see if we can get it to come in, if it'll make any difference. Oh yeah, big difference. Alright, almost there. This thing's so touchy, if you just breathe on it, it jumps. Right about there. Oh, that's pretty close. Alright, we're going to leave that one alone. So that's done. And now we're going to, looks like, adjust the other one and make sure that it's also set properly. Okay, for this next adjustment, I've now moved us over to the voltmeter, and we're going to actually look at the voltage. And what we're going to do is, this is a little bit unique. This bar antenna over here, let me see if I can get it in shot. This bar antenna, if you notice, has a slider on the outside. Most of them have a slug on this inside here that you turn. This has an actual slider that you move back and forth to peek out the bar antenna. And it's very touchy. It's hard to see on the oscilloscope. You really can't see the waveform deflect that much, but if we use our voltmeter, we can easily see it. So that's why we're tuned in here. So I'm going to slide this until we get it peeked out. And you can see right about, getting close. And that's about it right there, is about all we're going to get. Okay, so that's much better from where it was. There, very good. Okay, last but not least, we'll adjust the last trimmer on the capacitor gang, and hopefully that'll get us a little bit more. We'll see. Oh yeah, a little bit. Not much, but just a little bit. And there we go. And I'm thinking we're pretty much peaked out. And there you have it. So the AM section is now done. And that's it. That's all there is to doing the tuner on one of these. It couldn't be any simpler. There's no Lissajous patterns, nothing like that. Like on the SX-950s and some of those older ones, you actually have to do all that. Not so on this one. They make it pretty easy. So that's it. And I'm going to put this tuner together. We'll give it one last quick try, and we're going to wrap up this video, and we'll be done. Yeah, I'd say it's working good. Really pleased with how it turned out. The tuner's really sensitive, and thing sounds great. Performance numbers are good. I think the owner's going to be really happy with this one. So I think we're going to call this one a wrap. And glad you came along with me, and I'm glad you watched this with me. I had a lot of fun. Not all the time. Taking that thing all apart and putting it back together wasn't so fun all the time, but hey, that's what we do, huh? So anyways, thank you all for coming along. I know it's been a couple weeks since I did a decent video on one of these, so thanks for being patient. And as always, I wish you all peace, joy, happiness, and good health in your lives. And until next time, take care and stay well. Bye-bye.